All right, so this is the next part in our lecture on Chapter 8 in the industrial materials. Now we're going to be talking about forgings. A forging is basically a shaped metal part. Um, we use plastic deformation and the aspect of the fact that iron and our metals can be plastically deformed, and then we use hammers and large presses to basically force that metal into a workpiece, or force that metal workpiece into what we call a die, or between two flat faces. Now, again, forging is a process that has been going on for thousands of years. So, and is still a viable form today. So, of course, our industrial processes have gotten better and more refined as we do this type of work. So, we can hot work or cold work this, but most of the time hot working is the most common method. And when we're talking about that, we're talking about temperatures between 1900 and 2200 degrees Fahrenheit, where the hot steel still has a face cubic centered microstructure. And that allows for dynamic recrystallization to occur as the material is basically being pressed or forced into those dies or between the two flat surfaces to basically get us the desired properties that we want. So forgings themselves are very tough. So, and of course they have a very desirable grain structure there as we force that material. So we of course take large cast ingots. So, or we might actually take bars and other materials to use to start this out. So as you can see here, we could cut up multiple pieces. We can stack them together. We can do a lot of different things in preparing these billets and strands for the forging process. So a drop forge is probably the most common. It's also used called a hammer forge. So you probably, if you watched shows like Forged in Fire, you've seen this particular application where we can basically just use that hammer forge to flatten material between two flat surfaces. They have a huge amount of force that is applied to them. So, and of course, they can be using pneumatic cylinders for steam or air, or it could be a mechanical hammer that allows the drop there as well. And of course, as we do this, controlling the speed or the way that the amount of pressure in the drop is important for this particular application as well. We have hydraulic presses, so we can get a huge amount of force, the hydraulic force in here. So, and of course, that kind of pushes that down and helps to shape that material into the forged part. So, again, just kind of going over the rough procedures. I don't know how many of you are not familiar with this. If you, like I said, if you watched the shows or ever been to a, a forging demonstration or a blacksmithing demonstration, you've probably seen this particular application there, where we've got these different types of hammers that are more or less hammering and pounding that metal into the shape that's needed. We also have what we refer to as an open-faced or shaped die. So now those dies are taking the shape of the metal, and usually there are multiple steps to it as they move that billet from one die into another and basically press that down into the shape to give us the desired shape of the part in the die cavity. It's done in stages, so as it's kind of pressed from one shape into the other, and these can be as little as 1 or 2 stages. You might even be 3 or 4, depending on what the final part shape needs to be. So course, after it's done and completed, then we allow the material to cool, and of course it can be sent out for further heat treating at that point. Obviously, in any of these type of forging presses, they are very loud, so you want to make sure that you are wearing the correct safety and hearing protection to protect your hearing over time. Here are some of the applications that are used for forging. So steel scaffolding bolts here, you see a couple of different types of bolts. They are very strong, tough material, so forging is a great choice for these type of components. And because of the metal flow in the forging process, that improves the strength in these bolts. So we get that toughness that's required so that these won't fracture suddenly. And of course, if they're overloaded, generally they fail in a ductile fashion where it's a kind of a slow process to fail. So that way it gives workers time to get to safety in these particular types of applications. Ring rolling and for rivets and bolts, we can also use the ring-shaped parts to pierce these forgings and then kind of roll it into a ODID and thickness that's needed. So you can kind of see this particular machine. If we could zoom in a little closer here, you'd see a large tapered roll here that's more or less kind of compressing and flattening this, and there's another roller out here that is kind of bringing this in and changing the ID and the OD of that particular forged part as well. We do need to pay attention to inspections with forgings. So sometimes you can develop small cracks. So in this, and of course that will reduce strength, also cause premature failure in these parts. So oftentimes in the inspection process or different types of material testing, we can use dye penetrants to kind of look and detect any of these types of flaws. Sometimes if it's a highly critical part, you can also put these under X-ray and do other non-destructive inspection methods to test and make sure that these forged parts are in good condition and ready to move on to a customer as well. So we mentioned about grain structure and flow in forgings. So again, they do have a higher toughness, greater impact strength than cast parts. That's one of the advantages to using forging over cast parts. So, and largely that toughness and increase in impact strength is largely due to the grain structure that's flowing in the forging process. So that grain flow pattern remains once the part has come to room temperature, and of course we've got that recrystallized grain structure that is much more refined to give us that strength and the properties that we're wanting in that case as well. Your operators and the experience of the operators contributes largely to the superiority of the forged parts that are being made. So you do need to get some experience with this. Again, this is the learning on the job that you'll get as you do this. And pick up on making sure that you use and the controls and the number of magnitudes of hits. So the foot pedal, if you are kind of operating one of these mechanical dies or the hydraulic presses there as well, just getting and knowing and understanding when to strike and how much pressure to strike with is very important and crucial to getting a good forged part. So that's going to kind of end this particular part with the forgings. Remember, the advantage to a forged part is in that a stronger, tougher part than the casting. I'm going to end this here, and then we will come back and talk about extrusions next.